In this graph, we'll illustrate how to calculate the various surpluses using demand and supply curves under the assumption that underlying tastes are quasi-linear when a price floor is imposed in the market. We will use integrals to do this, integrals that are areas underneath curves. And it's sometimes confusing to do this because we're so used to drawing demand and supply curves that we forget that the integrals are actually taken over demand and supply functions. We begin by drawing the supply and demand curves that are implied by the supply and demand functions, which are given in equation 18.20. Setting these equal to one another, we can calculate the equilibrium price as being equal to 5, and substituting that back into either the demand or the supply function, we can calculate the equilibrium quantity to be equal to 1.6 million. We then impose a price floor, PF, somewhere above P star. The new equilibrium quantity transacted in the market will then be XDF, read off of the demand curve. This can be calculated by simply substituting the price floor into the demand function, as done in equation 18.21. Setting the demand function with PF equal to the supply function with P prime, we can then solve for P prime, which is the actual price that producers will receive once we've netted out the additional marginal costs they incur as they compete for the limited number of consumers. P prime is then given in equation 18.22. Given that the underlying consumer preferences are quasi-linear, we can then interpret the market demand curve as if it arose from a single representative consumer whose tastes are quasi-linear. In other words, we can interpret the market demand curve as a marginal willingness to pay curve and illustrate the blue shaded area as the consumer surplus after the imposition of the price floor. As always, producer surplus is the area above the supply curve up to the price that producers receive. That price here is P prime, and thus the magenta shaded area is producer surplus. The difference between PF and P prime is the additional marginal cost incurred by producers who continue to produce in a new equilibrium as they compete for the limited number of consumers. Thus, the green shaded area is the sum of all these marginal costs over all the goods that are produced in the new equilibrium. In other words, the shaded green area C is the overall additional cost producers incur in the new equilibrium as a result of competing for the limited number of consumers. This gives us the shaded deadweight loss triangle, which represents the lowest possible deadweight loss that is imposed on the market with this price floor. The deadweight loss might be larger because some of the green shaded area C may also represent deadweight loss, as the effort costs incurred by producers might be of no benefit to anyone else. The integrals used on page 658 of the text to calculate some of these areas are integrals over demand and supply functions, not demand and supply curves. We'll therefore next invert this picture, switching price to the horizontal axis and quantity to the vertical axis. We then invert the entire picture and see that the areas we've labeled now appear underneath curves rather than to the left of them. The blue and the magenta curves are now actually the demand and supply functions, functions of price rather than of quantity. We can now see that producer surplus is the integral of the supply function evaluated from a price of 0 to P prime, as indicated in equation 18.24. We can also see that consumer surplus is the integral of the demand function evaluated from PF to infinity, as indicated in equation 18.23.